So let's take a quick look here on the whiteboard. So back in chapter 2, when we were studying linear functions, we had all of these different forms. And so we learned about slope-intercept form. That's a favorite, y equals mx plus b. We had point-slope form. We also have standard form. So that was for linear functions. When we graph, it's going to make a straight line. So for quadratic functions, which is what we've been talking about over the last couple of days, we have some different forms as well. And so on the first day, we learned about vertex form, and we saw a benefit of that form is that we can immediately get the vertex just by looking at the numbers in the equation. So the h and the k told us our vertex. On Friday, we learned about standard form. That looked a little bit different. We didn't have any parentheses there, but we saw here there's actually still a process for us to solve for getting the vertex. It just took a little bit more work. And then today, we are going to learn about the last form of the quadratic. So this is called intercept form. And part of the goal today is to not only introduce us to intercept form, but to help us make some connections between the three different forms. And so you'll see right here at the top of our page, we have the general intercept form written out. So another way to write it is y equals a times the quantity x minus p times the quantity x minus q. So what's interesting about this one is that we have parentheses showing up again, but now we have two sets of parentheses. The p and the q represent numbers. They're not necessarily the same number. They could be different numbers. One other thing, though, that's interesting is you'll notice the number out in front is a. That's the same a in all three of our forms. So that is one constant piece that connects the three. So we're going to explore a little bit here on Desmos to see how this intercept form works. So we're going to take a look here at the first one together. So our equation here, we've got y equals x plus 1 times the quantity x minus 3. All right, so on Desmos, once you have hit launch the calculator, we'll just go ahead and type in our equation exactly as we see it. So I'm going to type in y equals x plus 1 in my first parenthesis. I'm going to do an x minus 3 in the second parenthesis. Now, one thing that's really beautiful about using Desmos, even nicer than your graphing calculator, is that you can click on points very easily, and it's going to tell you the ordered pair of that position. So for example, I could identify that there's two x-intercepts here. So an x-intercept is where the line or where the graph, in this case it's a parabola, crosses through the x-axis. And notice how I just clicked on those points, and it told me that I've got an x-intercept at -1, and I have an x-intercept at 3. Notice how the y value is always 0 when we're getting an x-intercept. The other thing that I can click on to easily identify is my vertex down here at the bottom, and there's actually a point in gray. I just have to put my mouse on it and click, and I can see the value of that point at the bottom. That's what we call our vertex, and I can get the coordinates, and I see that the x value is 1 of the vertex, and the y value is -4. So let's go ahead and transfer that onto our paper for this first graph, and you'll notice that we have a few questions across the bottom here that we can also answer. So we can notice here that we had x-intercepts at -1 and +3. And those are some features that can help us when it comes to constructing our graph. So let's go ahead and have a line or plot a point there at the x-intercept of -1. We also have an x-intercept of 3. I'm going to also notice down here at the bottom the coordinates of the vertex. It was 1, -4. So I'm going to go ahead and show that here on the graph. So one space to the right, down 1, 2, 3, 4, 4 spaces down. All right, now the only other piece that we need to fill in here is the axis of symmetry. So we talked a bit about this last week. We could draw the axis of symmetry into any parabola that we make by just doing a vertical dotted line going through the vertex. And so when we're writing out the equation, this needs to be the equation for a vertical line. We just need to look at the x value that is passing through. So this is going through an x value of 1. So our equation is simply x equals 1. And notice, just as we saw last week, the number in the axis of symmetry equation, that x value, is really just the x value of the vertex. All right, so I'm going to give you a little bit of time here on your own to do the next two graphs. So you're just going to go ahead and make the adjustments in the equation. You're going to type in the decimals what you see. You can also work together with a partner. If one person at the table has a screen, you can do this together. So go ahead and draw what you see, and then you're going to answer the questions, the x-intercept, the axis of symmetry, and the vertex. And let's just take a look here at this screen for what we should have seen on Desmos. So for this first part, we're just typing it in. We're drawing the graph that we see. We're identifying some of these components just based on what we're seeing on the computer screen. So on the second one here, it looks like we had x-intercepts at +1 and -2. And so what was interesting, though, is that the axis of symmetry ended up being at a decimal value. Because when we got the coordinates for our vertex, we saw that the x value of the vertex was actually -0.5. Well, if we were to draw in that axis of symmetry through -0.5, that looks like it would work. It looks like it is exactly the halfway point for our parabola shape. All right, when we take a look here at the last one, we got x-intercepts of +1 and +3. This one should have had an axis of symmetry of x equals 2 because the x value of our vertex was 2, and we ended up seeing that the y value of our vertex was -2. All right, so we're going to go a little bit further with this. So once we have this filled in, I want you to go ahead and answer questions 1, 2, and 3. So applying what you have seen and observed so far, we're going to address, well, how are P and Q related to the graph? How could we find the vertex without graphing the function? And then finally, we're going to try that in question 3 down here to see if you can find the vertex for this parabola without graphing. So let's take a few more minutes here to work through the questions all the way through the bottom of the page. You can also work and talk together with your group. Going back here to the first equation, so we had this x plus 1, and I'm noticing that we had an x-intercept of -1. Then we had an x minus 3, and we had an x-intercept of +3. Asa, would you share out what you wrote down? Like, what did you notice here? What's the connection?
It's like their x-intercepts is usually their sign. They would be related to the graph.
Beautiful. So it kind of looks like it's just the opposite sign as the number that we have in the equation. So we had a +1, it turned into a -1. We had a -3, it turned into a +3. And that will be true all the way through. So if we look at this one, we had a -1 in the parentheses. Well, it turned into a +1. Over here, we had a +2 in the parentheses. That turned into a -2. So the next piece of this, so when we look at the P and the Q up here in our equation, these are representing the x-intercepts on our graph. And the reason that it's changing to the opposite sign is because we have a minus sign that's in the formula. So we're subtracting P and we're subtracting Q, but P and Q themselves are the x-intercepts. Now, another thing that we can notice here is what's happening with the vertex, and how does the position of the vertex affect, or how is that related to where those x-intercepts are? And so if we take a look here at our axis of symmetry, like going back to our first graph, we can see that our vertex is exactly 2 spaces in from one of our x-intercepts on one side. It's also 2 spaces in from the other x-intercept on the other side. And so we're seeing here that the x value of this vertex point is exactly in the middle of where the x-intercepts are. This one is exactly in the middle of those 2 x-intercepts, and this vertex x value is exactly in the middle of those. And so if we could figure out the x-intercepts, we could figure out what number is in the exact middle. That's the x value of our vertex. And then it's kind of like what we did in class on Friday. Once we figure out the x value of the vertex, we could just plug that number back into the equation to get the corresponding y value. Okay, so let's check in here on the answers we have written down. So in number 1, we talked about how P and Q are the x-intercepts for the graph. And then a process for finding the vertex without graphing it, so without using Desmos, we notice that the x-coordinate of the vertex is in the exact middle of the x-intercept. We're going to find that x value, then plug that x value in, and find the corresponding y value. All right, so now we're going to apply this, and we're going to try a new graph altogether. So for question 3, we had the equation x minus 5 times the quantity x plus 3. So the first thing that we want to do is find our x-intercepts. And Chase, would you tell us, what did you get for those x-intercepts? Beautiful. So we're looking at the number in the parentheses here. Taking that out, it's looking like it's turning to the opposite sign. So that minus 5 in the equation turns into a positive 5. The plus 3 is turning into a minus 3. All right, so those are the x-intercepts. Now the next thing we need to do is we need to find what number is in the exact middle of 5 and negative 3, because that's going to end up being the x value of our vertex. So there's a couple of ways we can do this. It says to do this without graphing, but it doesn't say that we can't use the help of a number line. So what we could do is just think about drawing out a number line. This could represent the x-axis here, and I'm just going to put in a few labels so I can see all of the positions from negative 3 to negative 5. Can you tell from this number line how many spaces are in between negative 3 and 5? All the way across. 8 spaces all the way across. Yes, but then Christopher, how many spaces would it be to get to the halfway point? Wait, what did you just say? 4.
4.
Yeah, 4, right, because we have 8 spaces, 1, 2, 3, 4, 5, 6, 7, 8. There's 8 spaces from one end to the other. So if we're trying to find the exact halfway, let's go 4 spaces in on either side. Well, if I go 4 spaces in from the left or I go 4 spaces in from the right, I'm ending at the exact same position. That's going to be an x value of 1. So that's the x value of our vertex. It is always halfway between the x-intercepts. Now, another thing that we can do, if we don't want to draw a number line every time, or maybe we have numbers that are like really, really big, and so it wouldn't really fit on our page, is we could add the x-intercept values together and then divide by 2. So another option is to do 5 plus negative 3, and then divide that in half. So on the top here, 5 plus negative 3 is 2. When we divide that by 2, we're getting the same answer of positive 1. That is the x value of our vertex. All right, now that we know the x value, we are going to plug it in. So I'm going to say here we're going to plug in x equals 1 to get the corresponding y value. And where we're plugging it in is we're plugging it in for x into this equation up at the top. Now, how many x's do you see in that equation? There's 2 of them. So that means that when we plug in 1 for x, we have to plug in 1 2 times. We're plugging it in every single time we see an x. So I'm going to show that work off to the side here. I'm going to say 1 minus 5 in the first parenthesis, 1 plus 3 in the second parenthesis. So many of these evaluating problems with quadratics are all about order of operations. So we are going to go back to PEMDAS again. We do have some operations in parentheses here, so we need to do those first. So we can start by doing 1 minus 5, and we're going to get negative 4. Over here, 1 plus 3 is positive 4. Now we can do the final step of multiplying. So negative 4 times positive 4 is going to give us a y value of negative 16. And we're just going to plug that in for our vertex. If we were to graph this on Desmos to check, you should see x-intercepts at 5 and negative 3. If you scroll out a little bit, you should see a vertex at positive 1, negative 16. We are going to fill this in so that we have a place to reference how do we do the different things for all of our different forms. Because remember, one of our learning targets for today is to understand the connections between the three forms. All right, so when we take a look at this, we're actually going to start with, we're just going to go in order here from how we learned these. So we're going to start on the left-hand side with vertex form. And I'm just going to put a little reminder here that that's what we did on the first day. That was lesson 4.1. All right, so for vertex form, we had y equals a times the quantity x minus h squared plus k. So this is not what we did today, but this is going to be a little bit of a review from what we did on Thursday. So remember that from vertex form, the benefit is that we get the vertex very easily. Just from looking at the equation, it's hk. Now, one thing that we want to be careful of on this is that the x value of the vertex here, the h, was the opposite sign of the number that was in the parentheses, but the k, the y value of the vertex, was the same sign as the number that we have on the x. So that's what we did with vertex form. Now, the axis of symmetry is always x equals the x value of the vertex, whatever that is. So in this case, it's going to be x equals h. Let's go ahead and also fill in, I almost forgot this one, the parent function at the very top. These are the different forms of a quadratic. The most basic quadratic function we have is y equals x squared. Okay, let's fill in the middle. Now this is going to be reviewed from what we saw on Friday. So in lesson 4.2, we did standard form that did not have parentheses. Instead, it was ax squared plus bx plus c. And we had quite a different way of getting our vertex when it was in standard form. To get the x value of the vertex, it was a very simple little formula, negative b over 2x. So that's what you just practiced on the homework that you did over the weekend. All right, then to get the y value, we just plug in the x value of the vertex to get the y value. Now, just as we saw before for vertex form, the axis of symmetry is always x equals to the x value of the vertex. Well, in this case, the x value of the vertex is negative b over 2a. So that's the number that goes in our axis of symmetry equation. All right, next we have intercept form, which is what we did today. So that is lesson 4.3. And the formula for that is y equals a times x minus t times x minus q. Yes, Josie?
What about the intercept form?
We're going to talk about that one at the end. All right, so in the intercept form, we're seeing here that to get our vertex, we need to figure out the x value that was halfway between our x-intercept. Let's actually start at the bottom here on this one. Where it says intercept, I want you to write x-intercept. And the x-intercepts are p and q. But I'm going to write these as ordered pairs. So p comma 0 and q comma 0. So starting at the bottom. So the x value of our vertex is the halfway point between them. And so we saw that we could just add them together, p plus q, and then divide by 2. And I'm going to extend this arrow over what we just said over here for the standard form to get that y value of the vertex. It's exactly the same over here for the intercept form. We're just going to plug this value in for x to then figure out what the y value is. All right, so the axis of symmetry is always the x value of the vertex. So in this case, it's going to be p plus q divided by 2. All right, 2 other things we're going to fill in here. So let's go back to the middle one, standard form, and let's write an x in front of intercepts right there. There is a way to figure out the x-intercept when it's in standard form. We're going to be talking more about this in our next unit, but to give you a little bit of preview, this is when we do the quadratic formula. If you remember this from Algebra 1, if that sounds familiar at all, even if you don't remember what the formula says, the quadratic formula is what tells us the x-intercept for that form. You don't need to worry about doing anything with that right now. It's just a little preview. The other thing that I would like you to put in, so we have a little bit of open space here on the left, is about how you could find the y-intercept generally for all 3 of our forms. So we talked a little bit about getting the x-intercept for some of the forms. The way that it works for the y-intercept, and I'm going to put in parentheses here, this is for all forms, is that we just plug in x equals 0 and solve for y. So that will work every time. It doesn't matter the original form that it's in. All right, and then one other thing about the A value. So I mentioned this on the whiteboard at the beginning today. It's exactly the same A for all 3 forms. What that tells us, the first thing it tells us is what direction our parabola is opening. So the first picture that you see there where the parabola is opening upward, that's when A is a positive number. So I'm going to say that's when A is greater than 0. The other picture over here off to the side, this is when you have a negative in front. So remember, the negative is going to flip it over the x-axis. So that's when A is less than 0. Now, the other thing that can tell us is that if A is 1, it's the same basic shape. Over 1 space, up 1 space, over 2 spaces, up 4 spaces. That's if A is 1 or if A is negative 1. If you have a different number, like if you have a 2 in front, remember it's going to get vertically stretched, it's going to be a little bit skinnier. If you have an A value in front of a fraction, it's going to vertically compress it and it's going to get a little bit wider. So that's some other pieces of information that A can tell us. All right, so that's going to be a page where we can go back and reference how to do everything with our different forms. We're going to finish up here now, just looking at a few more examples and making some connections between our 3 forms. So let's go ahead and turn over to the next slide. All right, so we have a graph here, and we are going to begin by writing an equation for this parabola in vertex form. So let's remember at the start here that vertex form is the first one that we learned. A times the quantity x minus h squared plus k. All right, so let's identify our vertex here on our graph. So I'm going to label this as the vertex. I'm also going to write the ordered pair of the vertex. So the x value to the y value is -9. Another thing that I'm noticing here is that to get from one point to the next, I'm going over 1 space, up 1 space on either side, and then I go over 2 spaces, up 4 on either side. And I'm also noticing that the parabola is opening up, so that's telling us that A is positive because it's opening up, and we also know that it's 1 because it's not vertically stretched out or vertically compressed. We're following the same basic pattern as the original x squared. Now, if A is 1, you can put a 1 in that position. you don't have to write anything in the position. You can make it an invisible one. All right, then we're going to do x minus the x value of the vertex, which was 2. And then we're going to add on the y value of the vertex. Well, if we add -9, that's really the same thing as just subtracting 9. So that is our final answer in vertex form. Okay, now we're going to write an equation for the same parabola in intercept form. That was the new one that we learned today. A times the quantity x minus p multiplied by x minus q. Okay, so we already know that A is 1. And we need to figure out what are the x-intercepts, because that's what we're going to be filling in for P and Q. So noticing that I have an x-intercept at 5, and I also have an x-intercept at -1. Now remember, it's going to look like it turns into the opposite sign when it goes in our parentheses. So let's start each one with an x in front. For the first x-intercept, we're thinking about subtracting -1. Well, if we subtract -1, that's the same thing as adding 1. In the second one here, we're subtracting 5, but that's just going to make it look like x minus 5. So that's how we can go backwards, starting with the intercept, turning it back into an equation. All right, now here's what we're going to do in part C. So this step is kind of cool, because we're going to show that these equations are equivalent to each other by converting them to, when it says general form, that's another name for standard form. And standard form is ax squared plus bx plus c. Okay, so to turn it into standard form, we saw an example of this on Friday. This is where we're going to multiply the pieces out. So let's start with the first one, x minus 2 squared minus 9. So if you have something that is being squared, that just means that it's being multiplied by itself. So if x minus 2 is multiplied by itself, let's write it out. X minus 2 multiplied by x minus 2. We still have the minus 9 on the end. We don't want to forget that too. All right, now as far as multiplying the two quantities in the parentheses, on Friday, we saw that we have two ways that we can do this. We could multiply them out with the box method, or you can multiply them out with FOIL. The box method is just a visual picture of FOIL, so we're still going to get the same answer. So if we're thinking about that box method, so some of you raised your hand and said you would prefer this. We're going to set up the outsides with x minus 2 across the top, x minus 2 across the side. We're going to multiply each piece to get the components on the inside. So starting off, we've got x times x, which is x squared. Then we're going to do x times -2, negative 2x. For the next position here, we have another x times -2, negative 2x. And then -2 times -2 is positive 4. So let's go ahead and write out those four pieces. X squared minus 2x minus 2x plus 4. So those were the inside parts. And we're still going to bring down that minus 9. All right, now all we need to do here is combine like terms. So we get x squared minus 4x minus 5. I'm going to put my y equals in front. I'm going to circle that and come back to it so we remember that's what we got for the first one. Okay, now we want to turn the equation that we got in part B, we're going to turn that into standard form. So let's copy that down. That was x plus 1 times x minus 5. Okay, so because I modeled the box method on the first one, I'm going to multiply this next one out with FOIL. So we know that we're either doing the box or we're doing FOIL, because we have 2 terms in the first parentheses, we've got 2 terms in the second parentheses. I'm going to change colors here. I feel like the green is a little light. So we had x plus 1 times x minus 5. All right, so if we were to multiply this out with FOIL, we're going to do the first term times the first term. X times x is x squared. The outside terms, x times negative 5, we get negative 5x. The inside terms, 1 times x is 1x. And the last term here, 1 times negative 5, negative 5. All right, notice that when we combine the like terms here in the middle, negative 5x plus 1x is negative 4x. We're going to put a y equals in front. We're going to notice here that these are exactly the same. So that's how our 3 forms are all connected. All right, the only other piece that I want to mention here is about the y-intercept. You're going to see a few questions on the assignment tonight asking you to find the y-intercept of your equation. No matter what form it's in, we're just going to plug in 0 for x. And so, for example, if we were looking at something in vertex form, like what we have here at the top, and if the question asked you to find the y-intercept, you would plug in 0 for x right here. And then it's all about order of operations. So you would do 0 minus 2, which is negative 2. You would do your exponent here, negative 2 squared is positive 4. And then you would subtract at the very end. So here we have a y-intercept of negative 5. You can find the y-intercept in this next form by plugging in 0 for x. Order of operations has us do 1 times negative 5. We get the same y-intercept of negative 5. The easiest one to find the y-intercept is standard form, because when we plug in 0 for x here, everything just becomes 0 except for the number at the very end. So that's another thing that you'll see in the assignment.